Welcome back to another LeetCode slash LeetCode grind. A bit late in terms of when I shoot because I'm a bit sleepy, but yes, we are back again with another video. So yeah, I think yesterday we solved this question: longest substring without repeating characters. I guess the logical step would be try to solve this again, right? And then do another sliding window question or maybe a binary search question. You never know. Never know. Right? Yesterday we were doing function pointers, and I got to know about this the circular doom in C. So you might be reading this as well. But yeah, I think let's go. GG's, let's start. Okay, the question is given a string s. Okay, let's start at time. Given a string s, find the length of the longest substring without duplicate characters. A substring is a contiguous sequence of characters within a string. Okay. Yeah, so the way I think about this question is very simple. And so let's think about this, right? Let's say we have this, pretty much this thing over here. Before we even go into the code, right? Let's think we have this thing over here, right? Okay, so let's see. So the way we do this is something like we start with Z and we say, well, we have a substring. So this is Z, okay, that's not repeating. Then we go to X, that's not repeating. Then we go to Y, that's not repeating. And we get Z. That's kind of shit. So we remove this because that's the only thing, and because it's supposed to. So this is our window now. Now everything before this and to this will be removed, and so now this will be our new substring, so to speak, and we'll just calculate its length. Also, yeah. So we calculate its length. Then we make this another window over here. See how it's repeating. So we pretty much keep this, we remove this, and this is our new substring, so to speak. We come over here. Oh well, that's another y is repeating, so we remove y. First of all, calculate this length, so we know this is there. We make y over here, and we see z, we see z, and pretty much that's it, right? It's a sliding windows. We just keep on checking. But how do we implement this in code, right? And so the way we implement this in code is let's do something like I is equal to 0. Now while I is less than length of s, okay, and we will have a substring, right? So yeah, we'll have a substring over here, and in the NeetCode video we said we can use a set. Sure, right? Substring set, so to speak, number of unique characters, and right. Okay, so yeah, there's something like that. So we can say while I is less than length of s, right? We can say something like if s dot I not in substring set. um, how do we append to the substring, by the way? How to add elements to a set in Python. Okay, so we can say substring dot add. We can add this now because it's not in there. So this is pretty much equivalent to coming over here and saying, okay, is this in our substring already? No, it's not. Cool. So now our substring set will contain z. great. Now we come to x. Great, x is not here. Great. Then we come to y. Y is not here. Then we come to z. Oh well, seems like z is already there, right? So then you have to put another thing over here, else block. Okay, so essentially now what we're gonna do is okay, so this is our one of the substrings that we're able to form without duplication. But now क्योंकि z आ चुका है, right? Now that z has come, by the way, how will this increment? This will increment by this. हम लोग को क्या करना है? We will do very simply. We will say substring dot set discard. We will discard si, and then I will say substring dot set. Before we do this, we will say max length is equal to 0, and we will say max length is equal to max of max length and find length of set in Python. I know it will be len of that, but I'm just doing it so you know, like substring set. This is actually weird, yeah, to be honest. Like, I don't want to do this. Let's do this much better. Like, let's do something like substring is equal to this, uh, you know, and substring is equal to this substring. We first put that, and then we will say substring is equal to, and now pretty much as this is contiguous, right? We want to remove everything up including this, so we don't want to have this at all. So what we could do is substring dot index of si plus 1 this, so it pretty much takes from here to wherever that is, and right, and then we can do right. So essentially क्या हुआ, before we now include z, we first will the substring we have over here, we will put this in some max value to keep for accounting purposes, right? And then we'll have a substring which will update. So because this is contiguous, and we'll have like wk over here, we continue, we want to pretty much continue, but we can't just remove this and be okay, this is a substring. We have to remove everything that comes before it and including this. That's why we'll do something like this. This pretty much starts the indexing from after this value, which is over here, right? And then it will add the value that is there, and that is it, right? So it comes like to it. Now it will remove z. Before removing it, it will max it, then remove it, and then हम लोग को ये मिल जाता है. Great. Right, this solution is fine in that sense. Substring ये हो गया, I is equal to 0 हो गया, and max length 0 हो गया, right? And then we can say while I is less length, we will say something like if si not in substring, else, right? And we will say something like return max length. If it's not in the substring, we will just be like, okay, well, that's great, add that. If it is, then we'll say max length is equal to max length, length of substring. First of all, we just take the length of the substring, then we'll say now the new substring is substring dot index of si plus 1, right? So everything including that, and then we will say plus equal si, right? And then we'll do I plus 1 and we'll return the max length. Now if I run tests, it will fail some tests, because let's say if we have something like this, इसका reason क्या है? It's very simple. Reason is, let's try to see the test if it's like, if it passes the test on this one, print max length 3 works. Let's go x कितना x है 1. Great. The reason why it fails on this one is because कुछ नहीं है ना. क्या कुछ नहीं है नहीं, but this does not update it. Righty righty. सबसे अच्छा यही रहेगा कि हम लोग ये करते हैं यहाँ पे. This is redundant. Maybe there's an optimal way of doing this. Uh, um, hmm. This will fix the issue actually. Yeah, this will actually fix the issue. So the thing with this code is now Q, for example, Z. Great. Z is one of those things that it doesn't. It's fine. So we have Z now. Now ZX. Great. ZX को भी length में update करेंगे. I don't like this code because for example Z आए तो हम लोग Z आए क्या Z substring में है नहीं है तो हम लोग इसके बाद भी max length calculate करेंगे which is useless computation. ZX तब भी ZY तब भी. now जैसे ही Z आया एक ZXY इसके बाद ZXY यहाँ पे और यहाँ पे. So there has to be a better way of doing this. Even though I solved this, there has to be a better way of solving this where we are not calling that length wala bar bar. Even though it's like O of n, it's too much here. Let's see if we could. I have solved it, but I'm just trying to like optimize this. If it is not in the substring, we'll add this. The thing is, we are not calculating the max length until we find कि एक और डुप्लीकेट आ चुका है या 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 ये जैसे अब इसका वैल्यू क्या है आई है लेंथ क्या है 1 है लेंथ राइट. फॉर एग्जांपल मतलब ए बी 0 1 लेंथ 2. तो यहाँ पे आए हम लोग राइट. एंड क्योंकि यहाँ तक खाली यही रन किया है उसकी वजह से हुआ नहीं तो दिस मीन्स कि अगर ये सबस्ट्रिंग में नहीं है ग्रेट if I is equal to if at this point I think that is our if I is let's say like this then we will just do max length is equal to max length of substring because इसके बाद we know कि I will be not that. So this might fix the bug if the element is the last as of now. Okay, cool. Let's run this. Okay, so now it works. Let's see if I submit this. Okay, cool. If the element is last, then we don't need to do that. Cool. So we solved that. GG's. Right. NeetCode does this in a better way, sure, right? But yeah, this is the way I understand it, and this is still O of n, right? So that is good. We did reverse linked list. We did linked list cycle also, which I learned using that algorithm, which is you have a slow pointer and you have fast pointer, and while fast and fast dot next, and then we just keep incrementing it, and they will catch up to each other. If not, then not. How is this question easy? Like I'm genuinely confused. I tried solving this once. Obviously, my solution was of n square solution, which is kind of shit. Easy it seems like. Let's see that is there a discussion page over here. यहाँ पे तो discussion page होगा. Okay, let's see what the question is even to begin with. Yeah, let's start the timer. Why not? Um, पता नहीं यार मुझे मैं देखा हूँ या नहीं. Let's try to keep it 20 minutes. Let's restart and start. Let's go. क्या है? You're given an array prices where prices I is the price of a given stock on the ith day. ठीक है? You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction if you cannot achieve any transaction. Okay, right. So हम लोग को basically an array दिया है of prices जहाँ पे ith day पे जो price है that is price bracket I bracket close, and we need to choose a day and we need to find the maximum profit that we can get by buying a stock in one day and then selling it in the future, right? So essentially what is the profit over here? The profit is when you sell something minus buy. Now if your sell is greater than buy, you get a profit. Let's say if I buy something at $2 and I sell that at $3, well, guess what? I make 1 plus 1 profit. If the other case happen, if sell is let's say less than or equal to buy, well, this is no profit or loss directly, right? If I bought it at $2, sell at $1. Like if I bought something at $5, I sell it at $4, well, I lost $1, right? So that's not cool. Right, so these are the bunch of prices we are given, and then the question says 5. Okay, so the maximum profit we can get is 5. Why so? Is because if we buy on day 2, which is 1, so indexing is 1 apparently, and sell on day 5, which is 6, we get 5. Note that buying on day 2 and selling on day 1 is not allowed, so we can't buy on day 2 and sell on day 2 because that's like going back in past, right? So okay, let's try to see if you could visualize this question. So this is our prices. These are days, so these are let's say day 0, day 1, day 2, day 3. Let's make this longer. This is our day 0, day 1, day 2, day 3. 0, 1, 2, 3, 4, 5, 4, 5. Cool. So on day 7, this is 7, right? On this it's 1. On this it's somewhere over here 5. It's 3. Then over here we have somewhere on 6. And then we have somewhere over here at 4. Cool. And if we connect all of these dots, we'll see the stock goes down, stock goes up, stock goes down, stock goes up, stock goes down. And they say that the best day to buy is on over here and then sell it over here, right? Because you're buying at 1 and you're selling it at 6, so you get this much of, like, you get 5 as a profit. And so the most common sense thing would be let's do a O of n square where we choose the first thing, we choose the first date as our buy date, and we see what would be the profit on every other day in the future, and we keep incrementing the max profit wala, and we come over here and check ding, 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 that, right? But that would be very trivial, right? And our recommended space complexity is O of 1, O of n, sorry. So how do we figure this out? Okay, let's see. Okay, let's say I have a left pointer and let's say I have a right pointer. So over here our left pointer represents when we are buying it and our right pointer represents when we are selling it. Great. Now whenever our left is greater than R, well, this is kind of shit, right? Because as I explained over here, this is pretty much like saying that we're gonna buy high and sell low. That's not, we buy low, we sell high. So well, this is not the thing we want this to be, right? So what we would do, we just pretty much say, okay, well, like if we could buy at 1, then why are we buying at 7, right? We're like losing like 6 on that. So what we can do is we can essentially just not buy over here, right? What we can do is we can move, we can buy it over on L and then sell it on, now we just pretty much move it by one. You don't want to. And R will always be on the right side because it's in the future. Okay, this is past and this is future. Now our, in this case our L is less than R. This is great, right? This is our buy and this is our sell. So we are buying, no, we're selling, and this is great. This is around, so how do we calculate the profit? R minus L, which is 5 minus 1, so we get a profit of $4. So we just keep this in our sum variable. Now we keep changing our R because this is the lowest we have seen of buying something. So we keep our R, okay, pause. We keep our R intact there, right? And we come over here. Now again, this happens, that is great, which you want to move out because we haven't seen something smaller than our buy point. We calculate this, we move ahead to L, we move again to R. We'll say, okay, 1 minus that is great. And we come to this R and we check this and boom, that pretty much ends that over there. How do we put this in words? So we'll have a left pointer, and okay, let me just see the constraints. So we have prices, length, and we'll have a right pointer, and just to make sure this is, we will have something like length prices will be, I just calculate this once, right? We will have, then this is equal to, actually hell, go hell with this, which is equal to length of prices minus 1, right? This is our two things that we'll have at the moment. Now we'll say while left is less than R, we'll do some magic stuff and we'll return max profit. Then max profit, right? So we have a max profit, and this will ensure key even if it's 1, right? So we'll have 0 and we will have 0, and this will pretty much run as this. Now whatever I have done over here, now our, that means if this code runs, this means अगर एक ही element है, that means 1 minus 1 0, that one, अगर दो element है, so 2 minus 1 is 1 and this is 0, that means this code will run. In that case we will have some pointer over here and some pointer over here. Now let's do certain cases. If price is L, so in this case only, क्योंकि हमारा price is L बड़ा है, if prices L is बड़ा than prices R, we'll do something. So if prices L is greater than prices R, cool, my bad. So if we have prices L greater than prices R, what this means is we are buying on a higher price than R, which is kind of shit. Even if this should be equal as well, right? If these are equal, then well, that's kind of shit, right? I mean, I'm not making any profit, so to speak. So might as well just put my R and hope for something greater over here. If my prices L is greater than prices R, well, the first thing I'm bound to do is I need to go to R side because R is something that I need, and then to increment R to something else, right? Now if our prices L is less than prices R, this is interesting. Let's see, okay, this is bad. Elif, yeah, that's better. So if our prices L is less than prices R, well, that is perfect because we are buying in a less point and we're selling at a higher point. So what we will do over here is we will do max profit is equal to max of max profit, and we will do prices R minus prices L, right? I'm hoping that's the correct way of naming this. Prices, sorry, what am I typing? Right, right, perfect. And if this is the case, right, but so we are at a very comfortable point unless we'll just increment R, because at this point our R is greater than L. That means we are buying at a very lower point. Now if I increment R and I find a point that is even lower than our current point, then I'll go there, but at the moment I won't because मेरे पास अपना कम point है, right? Else will deal with the case, what if this is a nice edge case, what if our prices L is equal to prices R, right? This is a valid edge case that could happen. I need to fight for this. What do we mean by this, right? So let's imagine if in this case of our graph we had some day we have 5 and some day we had 5. Now, and this is our L and this is our R. Well, technically we're not making any profit. The profit is still zero, right? But we have a common fixture point. I mean, at this point, it doesn't really matter. I could even do something fine that I can put L over here and put R somewhere over here, or I could very well just say, R plus one, right? Okay, let's run this. Let's run. I think this should pass the test cases. I feel like it. I genuinely feel because my logic. Okay, my logic is flawed. List index out of range. Uh, okay. Why is it? Okay, so right now, chat. I'm so dumb. Chat. I am so dumb, chat. Um, this ought to be on one actually. This ought to be on one. What did I do? Why is this like this? Okay, I was like, what the hell just happened over there? Yeah, anyways, chat. This ought to be on one actually. Again, this. Why is this happening? Okay, this ought to be one. Why is that happening? Okay, this ought to be on one, right? Even though this is a bad way of checking this, but this will tell me if the test case pass or not. Okay, let's something's out of range. Okay, something is clearly wrong. Um, wait, just give me 2 minutes. Let me just clean up this code. Okay, so max profit. Okay, let's take this example. So हमारा L यहाँ पे है, हमारा R. I know there's a glaring mistake over here, but trust me, I know, or I don't know also. Now I'm seeing. Okay, so now L is less than R, right? L is less than R. Great, it works. Now if I index into L, क्या 7 greater than 1 है? Yes, it is, right? So what I do is I pretty much say, okay, well, L is greater than R. In this sense, you can see prices, L is greater than prices are clearly 7 is greater than 1. So I can say, okay, well, I'm gonna put it over here and then I'm gonna go to R. This does make this work, right? Let me just show the code. Okay, now we are in this iteration, right? Now is while R is greater than R. Now we are over here, right? Prices of L is less than 5. Great. That means our max profit will be updated and we will do prices R minus prices L. Great. Now we will do now we will put it over here. Again, this is working, right? I am so dumb. Yeah, no, it's I'm fine. Right? It's going. Okay, this is working. So again, this is greater. That means okay, we're making a profit, and we'll just update this profit. Right, great. We come over here. R. Again, we make a profit. Great. Again, this is only the one that is being updated. We make a profit. Great. I see the fault. So we come over here. We make a profit. Right. Yeah, and then um um right. So it can only go up until 5. Right? So because it can only go, I mean, obviously there should be that, and R can maximum go to 5 because that's the only range it can abide to. Yeah, so that makes sense. My bad. That's a dumb mistake because I think okay, L is greater than R because okay, but yeah, so obviously it has to be there and R has to be less than that, which is great. Let's see if this submits. If this submits in within 5 minutes, I'll be very happy. I feel like there's a test case I've not checked. Yes, okay. I knew it. We have 5 minutes. Okay, let's see what the issue is. Let's see what the issue is. Chat. Okay, so let's see what the issue is over here. So again, we have 0, 1, 2, 3, 4, 5, 6. We have our L over here. We have our R over here. Now, the first thing our code sees is our code is giving us 1, expected is 2. Crazy. Why so? Our prices L is greater, which is again the no-brainer. We don't want to buy it over here if we have a lower price to do. So we put L over here and we put R over here. Right, this is great. So our max profit till now is 1, right? Our max profit till now is 1. max profit now is 1. Great. We just now remove this, and now we come over here. Well, now L and R are equal, so to speak. And so what we do is we don't even calculate the max profit, because it will be 1, right? It will just be 1. And so we don't calculate the max profit. We just move away with this, and aha, I see what the issue is. So now, well, this is even lower than that, right? So what we do is, okay, I'm so dumb. What we will do is essentially we will say L is equal to R, right? And we will say R plus 1 instead of that. Okay, and so now what will happen is, now now this comes over here, and our R comes over here, and we say 1, but that's 1. And this works. Let's see if it passes this, because that makes so sense, chat. Yeah, that makes so sense. Let's go. We got this. Let's go. Easy. Easy peasy lemon squeezy. So, okay, I don't know why my interface is kind of jacked up. Let me just reload this. Did I do something that like mess with the font or something like that? Like, did I? I did not. Okay. Cool. We did pass, but this is like on a spectrum. It's very bad. Let's see if this was because of the latency or something like that. Okay, I even got worse cold than this. So look, guys, let me just turn on the light, because I feel like it's very dark out here. So yeah, much brighter now, I would assume. Yeah, so this is much better, a good solution, so to speak. Let's put it on LeetCode as well. So we'll have mental gymnastics. So right now we'll say max profit is 0, L is equal to 0, R is equal to 1. We'll say while L is less than to R, and R is less than length of prices. We'll do something over here. Before we do that, we'll return max profit. Now the three cases is if prices L is greater than prices R. In that case, we will say L is equal to R plus 1. LF, we can say prices L is less than prices R. In that case, we'll do max profit is equal to max profit, and we'll say prices R minus prices L, right? And we will say R plus 1. The else case, well, that means that both are equal, so it will do both of them. Yes, that's perfect. Right, I think the best thing next now we can do is just watch the video solution, because that will help us, internalize more of the concepts. I have the volume a bit high, so you could hear him give the video explanation.
Hey everyone,
Yeah, I
welcome
think that's
back
good.
and let's write some more NeetCode today.
Yeah,
So today let's look at LeetCode 121, best time to buy and sell a stock. So if you know a little about the stock market, the saying is usually buy low and sell high. So in this case, we're given an input array. Now each value represents the price of a stock at a particular day. And we are given one transaction, meaning we can buy on one of these days and then sell on another day. And we want a transaction that maximizes our profit, and then we want to return that profit. In this case, if we buy on day 2 when the price is 1 and sell on day 5 when the price is 6, that's what's going to maximize the profit for us. So as always, I'm going to draw a picture and show you that this problem.
one thing I notice is, if you know a way to represent the problem in a graphical manner, you're more than likely to solve it, because the graphical in humans are not great at looking just at a bunch of numbers and just be like, oh well, I understand the pattern of this, you're a super genius person, and good for you then. But for most I've seen, if you could represent something graphically, well, now they can see certain trends much better than if it were like a number.
Is actually not too bad, even the optimal solution. So on day 1, it was at price 7, and then it went down all the way to price 1. The next day, it went from price 1 all the way up to price 5. And we could just keep going with this, right? So next day went down, and the next day it went up. And the last day, it went down again. So looking at the picture, it's pretty clear that the max profit we can get is simply by taking the minimum here and the max here. And if we look at the actual values for that, we see that this is 1 this is 6. So the profit is going to be 6 minus 1, which is 5. But notice how there's actually a greater maximum than this one, right? Like this is 6, but this is 7. So why can't we just do this? Because then we get 7 minus 1, which is 6, which is even bigger than 5. Well, it turns out we know that time moves in one direction, right? We can't go back in time to sell at this price. So how are we going to solve that problem? Well, there's a pretty common programming technique, 2 pointers. So we're going to initialize a left pointer on day 1 and our right pointer on day 2, which makes sense. Right is going to be to the right of left. And so we're going to see what's the current profit right now from here to here. Well, it's going down, right? That's not good. It's negative. And in this case, left is going to be the day that we buy.
Why that's so many
right
sound in
is
the...
going to be the day that we sell. So the first thing you're going to notice is it's down, right? It's negative. This is not good. We don't want a negative profit. Why would we buy left when we could buy right? Right is less than left. Why would I pay 7 when I could wait 1 day and pay 1? So that's basically how the algorithm works. Since our right value is less than left, we're going to update our pointer left. So left is now going to be on day 2 and right is going to be on day 3. So now we see that the right value is actually greater than the left value. But what's the profit? The profit in this case is going to be 5 minus 1, which we know equals 4, which is so far our current max
Best,
profit.
yeah.
So for the current max, I'm going to put a 4. And in this case, since our left pointer is less than our right pointer, since we're buying low and selling high, that means we can leave our left pointer over here and we only have to update our right pointer. Now let's compare our left and right. Oh, and we're still selling. New max profit, 6 minus. Going to end up checking complete. We found errors but no array, so extra memory is brute force, even though we have. We can iterating through prices. Now we want to check, is this a profitable transaction? And how do we check that? Well, if prices of left is less than prices of right. Now if this is profitable, let's calculate that profit, which really update our map as well as the profit. But it might not be a profitable transaction, which of we can update our left pointer. Now regardless of
Yeah, so you did the same mistake as me. You would actually have to update your L to point to the new R. Pretty much. That is if the prices L is greater than prices R. If it's equal, then if it's equal, you could just do R plus. Like what did I do? I can did R plus, doesn't really matter.
the conditions, we want left by 1. If the left price is not less than the right price, we don't just want to shift our left pointer by 1. We want to shift it all the way to the right because we found a really
Lower
price
point.
over here. We don't just want to shift our left pointer by 1 because then it's up here. Cross this out. So we're in the clear. We found a very optimal solution for this problem. I hope it was helpful. Please like and subscribe.
Like and subscribe, bro. You know you got my like, bro. GG's. Thank you so much. Yeah. So we did one question. I'm tempted to do this one, which is also a repeating window question. Right? No joke. But I'm also tempted of doing merge sort. Bro, linked list questions, like, first of all, is linked list even used in production? Because I've seen many people talk about how, they don't even use linked lists in production. They're like, yeah, we don't use linked lists for production because, cache misses and just simple operations then become like a pointer juggling exercise. And these questions that NeetCode gave, I have no issues with them. But is this even used in production, bruh? Like, will I have to like reorder my list in such a format that I mean, at this point, I don't even want to use a linked list, right? Like, okay, you are given the head of a linked list, singly linked list. The list is represented as this. Read out the list. Ooh. What is this? Like, what are we doing? Not anything. What are we doing, bro? I'm genuinely curious. Like, what is the purpose behind this rearrangement? Anyhow, so exactly what is happening is this is our, let's say, 0 index, 1 index, 2 index, 3 index. What we do is we keep 0, we put 3 over here, and we want to put over here, and we put 2 over there. 0 n 1 n minus 1 2. What is the purpose? And is this easy? Don't tell me this is easy. Okay, this is medium. Okay, thank God, I'm happy. I'm like, this is easy. This is alternate pattern. Okay, like this is 0, this is 1, this is 2, this is 3, this is 4. So we do 0 4 1. So we go 0 4 1 3 2. Ah, you see what the pattern? We go 0 4. You see what's happening over here? Or am I the only one who saw that? So if you see this pattern is recognizable, so to speak, like a cycle of some sort. The pattern is something like you go over here, we go over here, we go over here, we go over here. So 1 points to 5, 5 points to 2, 2 points to 4, and 4 points to 3. Uh, how do I solve this? Let's think about that. So it's like pretty much we want this to point to the last element, and then the last element will essentially point to this. And then we want this to point over here, and then this one to point over here. एक ठीक है, एक काम करते हैं. This is singly linked list, bro. If this was doubly linked list, right, we could have done that back pointer shit. But let's assume we have a left pointer to the first element, and we have a right pointer to this. Now, first of all, what we do is we cut the tether over here, right? We cut, and we connect this to the right pointer. Now, the moment we connect to the right pointer, now we will increment our left pointer to point over here, and now the R will put it over here. Right, now we will change our right pointer to point over here, right, and this will point over here. Right, now our left pointer changes to this, this is like Pope color. Okay, so this is left and this is right. Okay, so pretty much what we do is we say, okay, while starting off, we will do left will point to right. Right, if this happens, our right left plus 1, so left will move ahead. After this, right will point to L, that means this will happen, and right will move ahead, matlab right will come over here. Right, so now 1 say 5 say 2 over here, and now we come back again front of this loop. Now left will connect to R, and left ahead आ जाएगा यहाँ पे. Now right will connect to R, and left ahead आ जाएगा यहाँ पे. And now जैसे यहाँ सब में आए, हम लोग इसका वाला पॉइंट राइट में करेंगे. This will be -1, so to speak. देखो भाई, ये सब तो ठीक है, how do you implement this? ये तो ठीक है, दिस इज तो वेरी मच सिंपल, राइट? एंड वाइल इफ दे कम एट द सेम लूप, मतलब वी नो कि अब इसका हमें नल में पॉइंट करना है एसेंशियली। देखो ये तो सिंपल है, इसको हम लोग इसका नेक्स्ट पॉइंटर फॉलो करके आ जाएगा। um, like what is the space complexity of this orphan? Wow, I mean, couldn't be something like if we can hold the address of each of them in memory, like yeah, memory भी, हाय यार, मार दो यार, मार दो जान से। Let's do one thing, okay? Let's do one thing. All nodes, right? And we will say current is equal to head. Now, one thing we'll say, uh, all nodes, okay? We'll say current is equal to head. Now, while current is not none, we will say all nodes append current, and current is equal to current dot next. Storing all the address of nodes in the list, right? So यहाँ पे क्या हुआ, you know, while current is not none, current none नहीं है, नहीं current none नहीं है, ऐड करो, current none नहीं है, नहीं current none नहीं है, नहीं ऐड करो, and ठीक है। Now um, left left node is equal to all nodes 0 and right node is equal to all nodes -1, ठीक है? मतलब यहाँ पे हो गया, right? While left node is not equal to right node, I think this is making sense. While left node is not equal to right node, हम लोग पहले क्या करेंगे, हम लोग पहले लेफ्ट को टेदर करेंगे राइट से एसेंशियली। सो लेफ्ट नोड नेक्स्ट, राइट? सो that is our first step, exactly right, that's our first step. So before we do this, we want to store the next value, right? Left node next is equal to ln dot next, so we store the 2 का value। I mean स्टोर करने की ज़रूरत क्यों है, वो तो हम लोग के पास है ही ना नोट में, लोग के साथ नोट में है ही, बट ठीक है यार। अब एल एन नेक्स्ट बेसिकली, एल एन नेक्स्ट आपका एसेंशियली क्या हुआ, ऑल नोट्स। अब ठीक है यार, कोई बात नहीं, एल एन नेक्स्ट इज इक्वल टू एल एन का नेक्स्ट, राइट? अब एल एन का नेक्स्ट इज इक्वल टू आर एन, राइट? तो मैंने क्या किया, मैंने बोला एल एन नेक्स्ट, ये मैंने कर दिया एल एन नेक्स्ट यहाँ पे सेव, मैंने इसको यहाँ से टेदर कर दिया आर से, ठीक है? मैंने बोल दिया एल एन नेक्स्ट इज इक्वल टू आर एन प्रॉपर, ओके डन। मतलब ये अब ये कट गया एंड ये बन गया, ठीक है? नाउ नेक्स्ट स्टेप वुड बी आर एन का नेक्स्ट इज इक्वल टू एल एन नेक्स्ट, राइट? एंड हम लोग एल एन नेक्स्ट एल एन इक्वल टू एल एन नेक्स्ट कर देंगे। मतलब अब ये हमारा एल हो गया, यहाँ पे मेरा एल हो गया, ग्रेट डन, राइट? एल को चेंज कर दिया। अब आर एन नेक्स्ट इज इक्वल टू एल एन करना होगा, तो पहले हम लोग कर देंगे आर एन का नेक्स्ट, यही प्रॉब्लम है। if this was a doubly linked list, right, ये problem नहीं आता, मैं previous pointer use कर सकता था. Okay, I think I have a better solution than this. I mean, if they're pointing the same index, that means the same thing, right? My God. So ln next is pretty much all node ln plus one. Um, uh, um, right? Right, and then we'll just do ln plus one. Right, so इसका क्या हो रहा है? ln x is essentially all nodes ln plus one, मतलब इसके बाद वाला, and all nodes ln का next is equal to all nodes rn, and then we do ln plus one, मतलब अब ln यहाँ पे आ गया. Now अब r की बारी, right? Now rn should store the value of rn, इससे पहले वाला वैल्यू स्टोर करके रखना है, right? In a sense it will be rn priv will be all nodes rn minus 1, right? And then we will do all nodes rn dot next. Now this should point to जहाँ पे ln point कर रहा है. This will be all nodes ln, and now this will come to r. ठीक है, now मतलब rn will become minus 1. Great. राइट, अब यहाँ पे आ गए. अब फिर से हम लोग ये वाला रूप फिर से रन रिटर्न होगा. मतलब इस लोग का सबको याद रखो 0 1 2 3 4, राइट. अब हम लोग यहाँ पे आए तो ln नेक्स्ट इज इक्वल टू ऑल नोड्स यहाँ, तो ये हमारा ln नेक्स्ट हो गया. ग्रेट. ऑल नोड्स ln डॉट नेक्स्ट इज इक्वल टू यहाँ पे. ग्रेट. यहाँ ओ ओए ओए आई this will point to over here, right? ये उसका next हो गया. all nodes ln dot next is equal to all nodes rn जो इसने इधर रखा था, and ln plus one इक्वल ये हो गया. ग्रेट, राइट. अब यहाँ पे हम लोग यहाँ डाल दिए. अब r का होगा कि rn मतलब ये हमारा rn ये है, राइट? all nodes rn dot next is equal to यहाँ तक आ गया, राइट? एंड देन rn is equal to this. नाउ अगर आप देखोगे तो r and l दोनों सेम आपके आ गए. मतलब सेम आ गए, मतलब इसका क्या मतलब हुआ? इसका मतलब हुआ ऑल नोड्स, दोनों को भी ले सकते हो, दोनों इक्वल नहीं है. नेक्स्ट इज इक्वल टू नन. Chat, if this works, right? Well, bro, it's gonna be crazy if this might work, because let's see. Yeah, this is not working, chat. It's getting all error because the test is taking too long. But that's kind of shit, because I don't want to even see it. Anyhow, reorder. इतना टाइम क्यों लग रहा है टेस्ट केसेस को रन होने में? Okay, let's just run this test case itself. Okay, cool. So let's run this. What? Unknown network error. What the hell? Chat. What? Uh, okay, that's crazy. Hopefully my code doesn't get lost. Well, I'll get very sad. Unknown network error. What? What's the error? What? Chat. Yeah. Uh, not that. I mean, like this. I'll just copy paste this code because I can't let this go. Can't let go of this code. This code is preciseless. Let's just do that. What? There's network error. What the hell? Please tell me my code is not gone. I'll be very sad. I would genuinely be very sad. Oh, I don't even have the code printed. Come on, man. What happened to LeetCode? Chat. What happened to? What the hell? What happened to LeetCode? What happened to LeetCode? Okay. I think everything is fine now. Crazy. Something is going with LeetCode. Is LeetCode down? What? Abe, tell me, is it down or not? Okay. Then, oh my god, it ran. Chat. It ran, chat. Guys. No way. Guys, it ran. What the hell? Bro, are you kidding me? It actually passed. What? I actually can't believe it. What the hell? Chat, it actually ran. Oh my god, guys. I'm actually shocked, bro. What the hell? Chat. Oh my god. Oh my god. I did it on my own. Oh wow. Oh my god. What? Okay, I don't know what to say at the moment. Um, okay, well, I don't know what to say. I'm kind of like flabbergasted, to be honest. Like, I was not expecting this to, like, this is pretty much my own. Oh, okay. Okay, I think the one way we can fix this is because our direct recommended is off one, right? So I think what he is doing is he's going to do multiple pass-throughs of the list essentially. Um, wow, yeah, it's crazy. I was able to figure this out on my own and maybe even pass all the tests. Wow, GG's, I guess. GG's. I guess let's end this by watching his video about it, right? And yeah, I think we'll just watch his video, and yeah, that would tell us a lot, right? Great, wow, solved it, crazy.
Hey everyone, welcome back and let's write some more NeetCode today. So today let's
Wow, man, that's was actually kind of like surprising, to be honest with you. LeetCode is just not being like we don't wanna. Wow, man, seems like our actual algorithm over here worked, so to speak. That is good. That is good. That is good. Wow, 7 milliseconds. Yeah, I mean, great. And the thing is, our constraints were somewhere like this, so something is wrong with NeetCode. Like, okay, we're able to get the green stars, which is important. Nice. Cool. Let's watch the video tutorial and then call it quits. Right? Then we have to make another video on C and stuff.
Solve the problem reorder list. So we haven't done a linked list problem in a while, and this is a pretty common and interesting linked list problem. So we are
Are we
given
recording? Okay, great.
the head of a singly linked list, where we have the first value, the next value, etc., etc., and we want to rearrange it into this order. And a better example would be, so for example, take this linked list, and we have 1, 2, 3, 4. That's a straightforward ordering, but we want to take the first value, leave it here, then take the last value, move it in the second position, then the second value gets pushed forward, and then the third value is going to go next. And so in other words, what we want to do is, given the original list, we want to take, okay, the first value, put it in the first position, then take the last value, put it in the next position, then take another value from the beginning of the list, put it in the next position, then take another value from the end of a list, and keep doing it. The problem name, we're just reordering this list. We're not actually going to be creating new nodes. We just want to take each node and then put it in the correct position in the output string, and then we don't have to return anything because we're just modifying this list in place. So there are many ways to do this problem. I'm going to be focusing on the solution that we can do in linear time. Basically, n is the size of the linked list, but we're going to do this without any extra space. And it's not too difficult to do this with extra space, but without extra space, it's a little bit more tricky, but it's also pretty doable. So that's what I'm going to be focusing on. So if we were using extra space, what we actually could do is take this entire thing and put it in an array. So each node goes in the array, and what we would do is we would take the first portion, leave it as it is, and then we would take the second portion and either reverse this entire portion or just go through it in reverse order. So, something like this.
And so I did the solution with O of n space complexity. An optimization or an improvement would be O of 1 space complexity with O of n time
One pointer at the
complexity.
beginning, one pointer at the end, and using that we would build the output list where we would say, okay, the first pointer is, if we built an array to do that. So the idea is going to follow similar to what I just showed you. We want to take the beginning of the list and merge it with the second half of the list, right? So this is the first half, this is the second half. We want to merge these together with alternating values, right? So this is going to go first, and then this is going to go second. So obviously, we're not merging them from the beginning. The second list is going to be merged from the end. But if we're not putting this in an array, how exactly can we do that? Because we're going to have one pointer at the beginning of the first array. We're going to have one pointer at the end of the second. I think I said array, but what I meant is list, obviously. We're going to have two lists. And so the first half of the list is going to be straightforward, right? We're going to take, this is going to be the node that goes at the beginning. Then we're going to take this pointer, shift it to the right. So that's pretty straightforward. But since we have a pointer at the end of the second list, and we take this node, we put it in the second position, right? We'll insert it somewhere in the middle over here. That's not impossible, right? We can do that pretty easily. But the problem becomes, okay, once we've inserted this node, then we want to move our pointer to this node, but the link is going the wrong way. The link is going in order, but we really want the link to be going in the opposite order, because when we traverse this second portion of the list, we're not going to be going from beginning to end. We're going to be going from end to beginning. So how can we do that without extra memory? Well, the easy way is, why not just reverse the links, right? For this entire second portion of the list, why don't we reverse every single link, and then we can do it pretty easily, right? There's no reason that we can't reverse the links. We're perfectly free to do that. So that's kind of what makes this problem a lot easier. There's going to be two phases to this algorithm mainly. We're going to take the second portion of the list, reverse it, and then we're going to take these two portions of the list and merge them together. This first, next this value, then this, right, etc., etc. The only other thing that I want to mention is when we're reversing the second half of the list, how do we know what is the second half? How do we know we've reached the second half, right? Starting from here is when we want to start reversing. How do we know once we get there? You could do it multiple ways. The easiest way is going to be a fast and slow pointer. So I'm going to have the slow pointer initially at the first and the fast pointer initially at the second node. We're going to be shifting the slow pointer by 1. We're going to be shifting the fast pointer by 2, and we're going to keep going until the fast pointer either reaches the end of the list or reaches the last value of the list. And once that is the case, we know that the slow pointer is going to be if it's an even list, you can kind of run through it yourself and see that it does work. But if it's an even list, the slow pointer will be at the halfway point, pretty much, right? It'll be at the end of the first list, right? So then what we'll do is say, okay, slow.next is going to be the beginning of the second half of the list. So that's what happens if we have an even number of nodes. What happens if we had a odd number of nodes? Let's see if the same thing works out for us. So if we had a slow pointer here and a fast pointer here, we'll shift the fast pointer by 2. It'll be over here. The slow pointer will be over here. Then we'll shift the fast pointer by 2 again, so it'll be at null over here. The slow pointer will be at this node. So I guess the question becomes, what, in this case, what's the second half of the list? Because obviously we have an odd number of nodes. Well, what we're going to say is this is going to be the second half of the list. Even though it's shorter than the first half of the list, it still works for us, because what the result in this case is going to be is basically, you know, we have this second half of the list. This is the first half. We're going to take 1 at the beginning. We're going to take 5 in the next position. Then we're going to take 2 in the next position, right? We're just basically alternating. Then we're going to take 4 at the next position in the middle of the list. And in terms of the beginning of the first, taking these lists and merging them, it's pretty straightforward when you look at the picture. Actually coding it is a little bit tricky because we're going to have several different pointers. But just to give kind of the rough idea, we're obviously going to have a pointer here, which is going to be the beginning of the first list. We're going to have a pointer here, which is, we're going to call it the second pointer, the beginning of the second list. Obviously, the link here is going to be going the other way. What we're going to do is we're going to take, okay, this pointer dot next, right? 1 dot next is, instead of being
Okay,
set
I
to
think
this
I'll
node,
explain this. I'll understand this later because now it's just going over my head. I guess, well, thank you for tuning in for another session of NeetCode Grind. It was very fun to solve one question by myself. Very happy, very proud. Gotta keep up the motto, and yeah, see you till the next time. See you later, alligator, I guess.